Hello everyone, I am Faruk Can Ünal from Yeditepe University. Today I am presenting a part of my PhD studies with Professor Dr. Yüksel Demir from Istanbul Technical University. It is titled as The Presentation of Local Data On-Site Through Augmented Reality. Throughout the design process, architects interact with a variety of data to inform design decisions. They need data about the surrounding context of the site while developing the design, during the site visit and analysis before starting a conceptual design. Due to the increased amount of data necessary for evaluation, a holistic view of the local data is needed. Digital technologies present great opportunities for architects to acquire and use local data. Augmented reality provides to deal with the interface between the physical environment and virtual environment rather than focusing one of these environments. It can be used in a location-based approach that enables to produce constructive relationships on information with the use of location. It offers an immersive experience of surrounding information from different viewpoints while on the move. This study focuses on a location-based augmented reality model, which provides contextual information about the site. Using such a model for the exploration of the site supports the architect to collect and analyze local data. This study introduces a model that can help architects to understand the spatial impacts of the surrounding context better, particularly during the site visit. Local data can be presented on site by retrieving and visualizing all the properties and details concerning. It is possible to make local data visible and reduce barriers access to data by using augmented reality. Before starting to use the model, the user should be ready on the site where local data to be observed. The model can be used on portable display devices because of the need to move freely on the site. Initially, the model sends current location information to request the related local data. Then local data is provided based on the selected categories to display on the site by scanning in a given field diameter corresponding to the current location. When the user looks at the site through augmented reality, surrounding local data is shown on the display device. It provides a special approach to data mapping on the physical site. There is a strong need for 2D representation to visualize the data in a proper form. The model breaks the constraints imposed by 2D representation, moving toward 3D representation of the environment. For this model, a particularly important aspect of the augmented reality is its ability to make the user feel naturally surrounded by local data. This model can give users powerful new ways to observe relationships and connections between the local data. As a sample to architectural use of the model from the site, topographical contour lines and legal boundaries can be visualized on the site. Generally, architects take drawings of the site from the local municipality to consider height changes and boundaries on the site. Then architects need to interpret these heights and boundaries for their designs without breaking the relationship with the site. This model can present height changes and boundaries from the digital drawings that can be provided open access from the local municipalities or national government databases. When evaluating the site from the architectural perspective, the use of the surrounding area and the built environment must be taken into consideration. This model can present land use and built environment data by covering the view of the site. The user of the model can easily evaluate current state with provided data for architectural design. In the determination of the model components, studies related to structures of the location-based augmented reality systems are taken into consideration. The current devices on location-based augmented reality use handheld or head-attached displaying. Handheld displays come to the forefront with the widespread access, while head-attached displays provide natural platform with hands-free working environments. For introducing the model, handheld displays are used because of being widely available, range from smartphones to tablets. Information browsers as an augmented reality user interface provide to monitor and control information that is registered to the physical site. When the capabilities of the information browser are taken into account, facilities of the filtration and the radar are the significant tools during the display of the site. Hybrid tracking based on GPS and inertial sensors are sufficient with the development of the model. Nowadays, mobile devices from smartphones to tablets are already equipped with GPS and inertial sensors. These display, interaction, and tracking types can be used to realize this model. The operability of the model is provided by an integrated workflow. The workflow of the model is extensively explained under the stages of data acquisition, data query, and data display. In the acquisition of data, commonly used methods and different methods which emerge with developing technology are discussed in relation to the model. The query and display infrastructure of the model is explained based on the working principles of the studies carried out in the field of location-based augmented reality. Focusing on the data need of the architect during the site visit and site analysis before starting a conceptual design, the proposed model provides data on site through augmented reality. Using such a model for the exploration of the site supports the architect about common medium, data classification, spatial approach to data mapping, holistic view, data visibility, representations with time component, data analysis, and taking note and sharing. By bringing architects into more direct contact with the site, the model facilitates to understand the surrounding local data in situ and supports the reasoning process to design. As local data can be made easily available within the context of the site, architects can carry out site survey more effectively and efficiently. The proposed model is presented conceptually to express its contributions from the architectural perspective. Besides, technical requirements for the operation of this model are stated with suitable components and workflow. Thus, this model is extensively handled by different viewpoints. As a further study, this model can be realized and developed as an institute design platform for architectural design. And thank you for your listening.